This is example number 1 for plane strain. So for this particular example, we're going to have some strains available to us and we want to find the stresses. Okay? So let's consider the following case. At a point on the surface of a plane stressed object, the measured strains are EXX 800 micromillimeters over millimeters, EZZ minus 150 microns millimeters over millimeters, gamma XZ is 500 mu rad. The problem is giving you the material properties for this object, and noise equal to 0.25. Okay, and I'm asking you to find your state of stress. So when you do this problem, the first thing you have to keep in mind that you have to say, what do I have? I have a plane, I have a point in the surface, so just think about, you got a point right there. That particular point has this. You measure the strains, and this is what the strains came out to be. So let's formulate our state of stress for this case. So your state of strain. Your state of strain is EXX. We don't have anything in Y. We have EXZ, EZZ, EXZ. So this is what we have in the problem. Just don't forget this is gamma XZ divided by 2. This is how we represent this here. So your state of strain is 800, 0, minus 75. Remember, half of what we have, 0, 0, 0, minus 75, 0, and then this is 500. Oops. This is minus 150. This is 250. 250. You can immediately see that this is a case of plane strain because all these are 0. You see, it's confined to the XZ plane. It's confined to that plane. So if I'm going to solve these problems now, I have to know what equations to use. And this is what I have, and this is what I want to find. Obviously, you will have these. Okay. And then in your problem, this guy will be non-zero because this is 0. Typically, it's the value, the normal value that's 0. That's the value that you're looking for. That's not trivial. Okay, so let's go ahead and start finding those values. So we know that your state of stress for plane strain is true for plane strain is sigma xx, sigma yy, sigma zz is equal to E over 1 plus nu, 1 minus 2 times nu, 1 minus nu, 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 1 minus nu, 1 minus nu, times EXX, EYY, EZZ, and just note that EYY is actually equal to 0. Okay, so this is 0. Okay, so if I replace the values inside here, I find that the answer is nu multiply 1 minus nu times EXX plus nu EZZ, 1 minus nu EZZ nu EXX plus EZZ, 1 minus nu EZZ, nu times EXX. Just to review the way we do this, we multiply matrices. You multiply E times the first component, EYY the second one, EZZ times the third one, and you add the terms. Okay, so when you multiply the second one, this is nu times E plus plus EXX, and then this is 0, so this terms goes to 0, and multiplied by this is what you get. And so these are these stresses, okay? And to find your shear stress xz would be nothing else than G times gamma xz, okay? So I know my G, I know my gamma, I can basically replace all the values in here, and I'm going to do that in the next slide. So sigma xx will be 200 megapascals divided by 1 plus 0.25, 1 minus 2 times 0.25, 1 minus 0.25, EXX was 800. Don't forget it's 800 microns. So it's what you place in here is 800 mu then this is 150 minus 150 microns, and this gives you a value of, so all of this gives you 320. This first term gives you 600. Second term gives you minus 37.5. Then you basically get the answer is 100 kilopascals. You have to work out the units. Remember to get megapascals here, micro. So micro and mega basically becomes 1. So you have 10 to the 6, 10 to the minus 6, so that gives you 10 to the 0 is 1. And this is the value that I got for sigma xx. Okay, so let's go to the second one. You can pause the video if you want to. I'm going to keep on going. So you got the first term, and that's multiplied by the second term right here. That is 0.25 multiplied by the value was 800 minus 150. And if you do the math, this gives you 320 multiplied by this whole thing gives you 162.5. And when you multiply this, you get 52 kilopascals. The last term that we want to do the very last term we want to do is sigma zz, and what goes inside here would be minus 150 0.25 multiplied by 800, and that gives you a value of, let's calculate this. So this gives you minus 112.5 plus 200. This gives you 28 pascals. Okay, so then there's one more stress that I need to find, tau xz, and that would be g times gamma xz. And I know that g is equal to E. The problem doesn't give me that value, so I can find it. And that gives you a value of 80 megapascals. And the value of gamma from the problem was 500. So microns. So it's 80 times 500. Just remember the microns multiplied by mega is actually equal to 1. So this gives you 40 kilopascals. So if I build my state of stress now, my state of stress for this plane of stress, for this plane strain problem is 180, 0, 40, 0, 0, 40, 40, 28, and 52 kilopascals. So this is your state of stress for this problem. This is how you would calculate state of stresses given state of strain. So I have my strains. You have to know what plane they're confined to. They're confined to the XZ plane because these are all 0. So I know that these have to exist, but it cannot be 0 because it's a case of plane strain, so this cannot be 0. Then these are the equations that we'll use for this problem, and I can get my state of stress. So this completes this example.